Welcome to a new IoT Friday. Last time we said that today we're gonna have a live session, IoT Friday live, but because of organizational reasons we had to reschedule it, sadly. But today we have a very nice topic. I'm Steven.
And I'm Tom. And your next design contains a dedicated chip. We see dedicated chips in the news lately with Qualcomm releasing its new Snapdragon 3100 chip, but also Apple doing the release of the new iPhones and also announcing that they added the A12 Bionic chip. And both chips are responsible to take over specific tasks, but also to make the device that they're in more energy saving. So
wait. So you're saying it has a dedicated chip, but that you mean it has multiple chips,
right?
One doing a certain task and the other one doing another task, and thereby having dedicated chips.
Exactly, yes.
Okay.
Multiple chips with dedicated tasks.
So co-processors that can take over a task or are only designed to do one specific thing.
Yeah, and if you talk about energy saving, how does that work? This dedicated chip is very tiny, for example, or has a part that is very tiny that only works when the rest is not needed. So you save a lot of energy. Yeah. And all the heavy chips ramp up when the calculation power is needed or that specific task is needed.
Yeah.
So in the case of a smartwatch, for example, if you're sleeping, then the watch maybe only wants to see now and then what your heart rate is.
Yeah, so it's going to have a very dedicated tiny chip that only measures heart rate, which is a simple LED.
Sure.
And then saves that, and later, when the whole watch comes back to life, stores all the data and does the calculation on it.
Yeah. So the other chips that are responsible for the display, for the graphics, etc., they're not needed when you're asleep, so they shut down and you save a lot of energy.
Yeah. So let's take this a step further. It can be an IoT device. It can also be a big robot or a car.
Yep.
Let's take it to a household device such as a robotic vacuum cleaner that has many things. Could have a camera, it has sensors to make sure it doesn't bump into walls.
Right.
It has the vacuum cleaner itself.
Yeah.
It has the wheels.
The wheels and the motors controlling them.
Yeah. So let's look how a dedicated or actually a separated design looks like.
A distributed design, yes. Well, of course you can add or distribute the separate tasks that you just described, or each can have its own chip to do stuff.
Yeah, and so controlling the wheels, the driver of the wheels has a chip and it's only responsible for driving.
That. Yeah, exactly. And there's one chip that is only responsible for controlling the engine or vacuuming. Yeah. And there's one chip that only looks at sensor data coming in, and maybe another chip for looking at the camera feed that's coming in.
Yeah, so to give an example why this is very powerful, let's say that the wheels need to spin because the sensors say you can drive forward 3 meters. But halfway is 3 meters, there's something stuck under the wheels and thereby consuming too much power. And this dedicated chip can sense it and stop the wheels for a second, drive backwards,
for example,
see if the power is okay, and then start driving forwards.
Yeah.
And this is only in concern of this only chip, but the other chips don't even know that this is happening.
Sure.
Because a team or a person writing code for this can focus solely on everything that is concerned to driving the motors.
So you introduce a separation of concerns or a separation of tasks for a product, in this case the robotic vacuum cleaner.
Parts can be special, can be smarter, without the whole team or the whole product team even, so there can be multiple teams, needing to understand every other part of the product.
Yeah, and creating a needlessly complex design of your product. In this case you are separating concerns, separating tasks, and the design will become simpler. So
for expanding or making changes, it's a lot easier. If you have a new sensor or a new part that you want to add to this product, or maybe even changing the product, the motor drivers can stay the same, the sensors can stay the same, but maybe instead of a vacuum cleaner you want to make a mop out of it. So only the vacuum part needs to have a separate or a different controller controlling the mop.
Integrate it into your system and you're good to go. And one thing that you really need in distributed designs that we cannot go without, you have to implement a great API between all those separated tasks.
Interfaces
Yes,
between the chips.
so it's APIs in your embedded system instead of APIs of systems to systems.
Yeah, so taking APIs that we already know for years in
Yeah.
cloud and mobile applications, we're taking that
Yes.
to embedded systems, and thereby making a very strong system.
So in the end, the product is a better product.
Yeah, true. So, in your next design, look at how you can utilize this new way of designing a system by separation of concerns, by using dedicated chips. I hope you find this topic interesting. This was another IoT Friday, and if you have any questions or topics that you want us to discuss, let us know.
Connect to us and see you next time.
Bye.